Today, we will tackle about the Archimedes principle. But before that, we should know first who was behind that principle and how did he came up with those fundamentals.
Archimedes of Syracuse was an ancient Greek mathematician, physicist, engineer, inventor, and astronomer. And basically, he was the one and only person who was behind the Archimedes principle.
In his treatise on hydrostatics, on a floating bodies, Archimedes states, any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object.
The weight of the displaced fluid is directly proportional to the volume of the displaced fluid. The weight of the object in the fluid is reduced because of the force acting on it, which is called upthrust. In simple terms, the principle states that a buoyant force on an object is equal to the weight of the fluid displaced by the object, or the density of the fluid multiplied by the submerged volume times the gravitational constant g. Thus, among completely submerged objects with equal masses, objects with greater volume have greater buoyancy. In the diagram, the two blocks are the exact same size or volume. They are made of the different materials, the wood and the steel. Since they are the same volume, they displace the same amount of water. If you were to weigh the water that is displaced by each block, it would be the same. The first case is for an empty container. If the buoyant force upwards is more than the weight downwards, then the object is called positively buoyant and it will float. For the second case, a container which is half filled of salt. If the buoyant force upwards is equal to the weight downwards, then the object is called neutrally buoyant and it will stay in place. And now for the third case, a container which is completely filled with salt. If the buoyant force upwards is less than the weight downwards, then the object is called negatively buoyant and it will sink. Mathematically, the Archimedes principle formula is given as F is equal to the sine of rho multiplied by G multiplied by V, where F is the buoyant force of a given body, the sine of rho is for the density, G is for the acceleration due to gravity, and V is for the volume of the displaced fluid. For you to understand more the Archimedes principle formula, let's cite an example. A ball of mass 2 kilograms having diameter of 50 centimeters falls in the swimming pool. Calculate its buoyant force and volume of water displaced. Solution. The givens are mass of water m is equal to 2 kilograms and the diameter of the ball d is equal to 0.5 meters, r is equal to 0.25 meters. The volume of the sphere V is equal to 4/3 pi r cubed. Substituting the r cubed will come up to 4/3 pi 0.25 cubed. Then we will have the answer 0.0208 meter cubed. Hence, the density will be given by mass over volume. Substitute the mass is equal to 2 kilograms divided by the volume, which is 0.0208 meter cubed. Then we will have the answer 96 kilogram per meter cube. The formula for the force is given by F is equal to mg. Hence, the buoyant force will be F is equal to 2 kilograms multiplied by 9.8 meter per second squared, and that the answer will be 19.6 newtons. The Archimedes principle formula is given by the force is equal to the density multiplied by the gravitational constant multiplied by the volume of the displaced fluid. Hence, the volume of the displaced fluid is equal to the force over the density multiplied by the gravitational constant. Substitute the values of the force, which is the 19.6 newtons, the density, which is the 96 kilogram per meter cube, multiplied by the gravitational constant 9.8 meter per second squared. That will give us the result 0.0208 meter cube. Therefore, the volume of the given body is equal to the volume of the displaced liquid.